Okay, hello Cloud Gurus and welcome. We're going to explore my solution to the VPC challenge lab I gave you. Okay, on to the firewall rules. Now, I have more rules here than will fit on my screen, but that's not the only reason why I'm going to go through them in two sets. I'm going to filter these rules into the ingress ones and the egress ones. So, just to make sure we're on the same page here, egress rules apply whenever there's any connection that starts within the VPC, regardless of where that connection ends. Is the data allowed to get out from or egress this particular instance? Ingress rules, on the other hand, apply whenever there's any connection that ends within the VPC, regardless of where that connection starts. Is the data allowed to get into or ingress this particular instance? If a connection both starts and ends within the VPC, then it will need to be allowed by both sets of firewall rules. Alright, whenever some traffic is being checked for whether it should be allowed, Google starts with the lowest numbered rule, looking at the priority column of that particular type. Google then checks whether that traffic matches this particular rule. If it does match the rule, then the result, or action, is decided, whether it's allow or deny, and Google stops looking at more rules. If it doesn't match this particular rule, though, then nothing is decided yet, and Google moves on to the next rule to check that one. And so on it goes down the list. This is why when you're looking at this firewall rules screen, you should generally filter it by the type you care about, whether it's ingress or egress, and then sort it by priority in ascending order. This lets you work through the logic that Google is going to work through, so you can see both what would happen speculatively as you're considering different things, and you can figure out what did happen when you're analyzing a result that you've actually seen. Okay, now before we dive into the firewall rules, here are the instances that I have running in my setup for checking all the connections. In particular, I want you to notice that there are two extra instances here that weren't a part of the stated expectations for this challenge lab. This is something that you should always consider though. What happens in the future? How should the things that you set up behave when something changes? Like some other instances being added to this VPC, for some other purposes than the ones that drove our original design. You could imagine that some of these extra instances might be for something like background processing, doing batch work, running things on a timer, or really a completely separate app. And if that thing were supposed to be exposed publicly, you would of course add additional firewall rules to let connections through to it, but you would have to go out of your way to open things up. In general, a security principle to follow is to default to closed. New extra instances should not get any special access to any of the existing internal instances. And neither should any existing instances get access to any of the new instances. And actually, new instances shouldn't get access to any other new instances either. Like I said, things should default to closed. Now I think that this is a good time to remind you that you can stop watching this video at any time to go back and explore your own solution. Do come back and watch the rest of this video eventually, but the less of this that you need to watch before completing it yourself, the better. Okay, so for all of the different connections that could involve some instance in this list, I want you to think about what should happen. I count 15 materially different source-destination pairs. The backend trying to connect to the front end, that's one. An extra instance trying to connect out to the internet, that's two. You could keep going on like this. Now, if you have some background with software testing or QA, you may already recognize that what I'm talking about here is defining an exhaustive set of test cases using combinatorial testing. And this is really just an aside in case you're really curious, but since we only have two variables here, the source and the destination, this combinatorial testing will actually be equivalent to what is also called pairwise or all pairs testing. In any case, let's walk through all of these test cases, but let's start with the requirements that we've been given, the ones that were spelled out in the challenge. The verification part started out by saying, from Cloud Shell or your computer. This is talking about the situations where, when you're using Cloud Shell, you try to connect from there to somewhere else. In particular, what we care about is trying to connect out to one of the front-end, back-end, or extra instances on this list. It goes on to say that you should be able to ping the front-end instances from there. So let's represent the expectation of a successful connection from Cloud Shell to our front-end with a little check mark. The next line says, cannot ping back-end instances. So we'll use a little X to note that that particular connection attempt should be refused. If we try to ping the backend from Cloud Shell, it should fail. The next line of the requirements says when SSH'd to a front-end instance. And that means that we really should be able to SSH to these instances. If we can't, then how are we going to do the tests? The tests of connecting out from that front-end instance to other places. Now, the first thing spelled out for the front-end instances is that you should be able to ping the back-end instances. The next one is that you should be able to reach out to the internet and ping google.com. The next line of the challenge says when SSH'd to a back-end instance. This means that we should be able to SSH to these back-end instances. And this is something that people can trip over if they try to achieve the other back-end instance requirements by doing something like removing the IP addresses or removing the routing to the internet gateway for those back-end instances. But assuming that we can SSH to those back-end instances, now we're looking at the connections that you might make out from those back-end instances. The challenge says that we cannot ping front-end instances, so we put an X there. We cannot ping google.com, so we put an X next to the internet connection. And we can ping other back-end instances, so we put a check mark there. So now we've marked down all of the stated requirements. But what about the implied ones? In particular, what do we think should happen to the extra instances? Well, I would say that if those have the OpenSSH tag applied to them, that you should be able to SSH to those as well. And if we think about the connections that we might try to make from those extra instances, that pretty much completes this matrix. We now have 16 different source-destination pairs, and one of them, connecting from Cloud Shell to the internet, does not involve any of the instances in our VPC. That's how we get the 15 test cases that I mentioned. So what's our expectation for the things that we haven't filled in yet? Well, one of the things I think we can say is that connecting to the front end is pretty much always allowed, whether it's from another front-end instance or from an extra instance in this VPC. The front end is generally open to connections. It's only the fact that the back end is supposed to be closed off to outgoing connections that sort of limits its access to the front end. Another thing that I think we can be pretty confident about is that the extra instances should not be able to connect to the backend. Access to this backend should be restricted to only the specific front-end instances or other backend peers. And also, since the backend is supposed to be so isolated, it should not be able to connect to the extra instances either. Now, if we think about adding extra instances to a VPC, we would generally expect that it should not be publicly accessible. So a connection from Cloud Shell should generally be refused unless we do something specific to open it up. But more than that, we also said that other instances that already exist in the VPC shouldn't get access to those extra instances by default either. So of course that includes the front end not being able to connect to the extra instances, but it also means that new extra instances should not be able to connect to other extra instances. The last two spots on this matrix are extra connecting out to the internet, which by default we let things connect out even though we block things coming in. And if you happen to be using Cloud Shell, pinging google.com should not be a problem, so we may as well just put a checkbox there too. Okay, now that we're looking at all the different test cases, I have a question for you. What does this teal box represent? Feel free to pause the video to think about this for a bit. Do you have an answer? Well, this box represents the connections that originate within the VPC, and that means that these connections will all be affected by our egress firewall rules. Ingress rules affect a different set of connections. Ingress rules affect these ones, all of the connections that terminate within the VPC. Well, ingress rules also affect these SSH ones too. The SSH connections are also destined for instances within our VPC, but we special case those based on them being TCP port 22 traffic. So let's look at the ingress rules first, because they're generally the foundation. First things first, if an attempted connection does not match any of the listed firewall rules, then it will always match the implied rule to deny all ingress. I've just listed that rule here to make it explicit, but me adding this line has no impact whatsoever on what actually happens. This is what Google does automatically, even if you don't do anything. And remember that the terms ingress and incoming don't mean that the connection is coming from outside the VPC to inside it. They just mean that the destination of the connection is inside the VPC, and the source of that connection might be outside or inside the VPC. Next, let's quickly take care of all the SSH connections. These are pretty easy. Make a rule that matches early on in the checking. This rule will match all TCP port 22 traffic, meaning all SSH traffic, that is destined for any instance in this VPC that has the open SSH tag network tag applied to it. Because the filter is 0.0.0.0/0, that means that the IP address of whoever's trying to make this connection does not matter in whether this rule will match. It will always match. Next, let's take a look at the stated requirements, the data that we're supposed to let pass through. We can add a rule to allow incoming to the front end. Again, regardless of who is trying to make the connection, we will always let it through if it's going to one of the front end instances, meaning one of the instances that is using that front-end service account. Another connection that we want to explicitly allow is the front-end connecting to the back-end. Here we say that this rule will apply to allow the access into the instances using the back-end service account, but only when the connection is being made from an instance that is using the front-end service account. And again, the protocol is ICMP here because we're trying to allow ping traffic. The last connection that we want to explicitly allow is the backend connecting to the backend. This is just like the last one, except the service account allowed as the source here is the backend. But there's one last rule to look at. So what do you think that is? Well, you might also get some hints by where it's located on this screen. You might ask yourself, why is that allow incoming to front-end rule further down? And it's because this is the rule that blocks connections from the backend. All of them. But actually, not really all of them. So again, here's another opportunity. Think this through. What connections from the backend are not going to be blocked by this rule? Well, first of all, there's the obvious one of the rule right above it. Connections that are made from the backend to the backend on ICMP are going to be allowed. And because the priority of that rule has a lower number, Google will allow that connection and then stop looking at rules. But there's something else too, and if you haven't figured it out already, then maybe this will give you the clue. Remember our breakdown? What part of our test matrix is impossible to handle with only ingress rules? That's right. The connections that originate within our VPC but are destined outside of it, traffic outbound to the internet. And that's why we also need some egress rules. Now, just like the ingress rules, the first egress rule to look at is the one that's implied. If none of the other rules match, Google will always allow egress. You could change that if you wanted to by adding your own default to deny egress rule, and that might make sense in some circumstances, but that's not what we assume we need to set up in this case. But we did have a requirement that we needed to block the egress from the backend instances. But because we're security-minded, we don't just block the specific thing that we were told to block. We want to block everything that wasn't specifically allowed. So that's why this particular egress rule says that the backend is not allowed to make any connections outbound. Of course, there was one specific connection that should be allowed, and that was the backend connecting to the backend. Unfortunately, at the time I'm recording this, Google doesn't support setting a service account filter on an egress rule, but that's okay. It's really not that big of a deal. As long as we limit egress from our backend to only instances within our VPC, then those connections will also need to pass through the ingress rules. So the rule that we set here is allowing that kind of egress. And this is why, much earlier on in this particular lecture, I pointed out the IP address ranges of the two subnets. You could quite reasonably argue, if you wanted to be even more secure, that I should really restrict the IP address ranges in this rule to only those specific subnets that I've already created, but I felt like this would be a reasonable enough shortcut. The full IP address range that's allowed is only private IP addresses, so this shouldn't allow any access to the internet, and the rest of the rules that we've defined should handle things like adding more subnets, and I think you would only have more things to consider if you started peering VPCs. Now the next thing to do here is to check this out. I was originally thinking that I would record myself making a bunch of these connections from one instance to another, but I'm not really convinced that that adds all that much value. I would rather that you go and try it out for yourself. Don't just assume that what I've shown you works. And who knows, maybe you'll catch a problem in what I've done, or maybe a problem in what you've done. But when you are doing this, apply your scientific thinking skills. For each of the connections, ask yourself what is it that you expect to have happen here? And then when you do try to make that connection, did it actually connect? Why or why not? Can you figure out which specific rule it was in your firewall rules list that applied to that connection attempt to either allow it or deny it? And then for each one, think about what you learned here, both in terms of how the system works and in terms of what changes you might need to make to your Challenge Lab setup. I want to point out here that setting up firewall rules like this really is a type of computer programming. Sure, you might be adding these particular rules using the console UI, but you're giving Google a list of instructions of what to do in different circumstances. You're saying that every time data is being sent in your VPC, Google should run your program. First, check that lowest numbered priority rule, check to see whether it matches, and if it does, then you've arrived at a conclusion. If it doesn't match, go find the next highest priority number and check if that one applies, and continue on down the list. If you were writing this in another programming language, you might use a series of statements that started with if and then continued on else if, and then finally at the very end, it would say else, do that default implied action. You're not programming in Python or Java, but you are programming in Google's VPC firewall rules language. Well, there you have it. I hope you've found this to be a useful breakdown of this Challenge Lab. As always, if you have any questions, please do let me know. If not, I'll see you in the next lecture. Thank you.